Hello and welcome to What's Up with Energy, a GridX podcast. I'm your host, Georgia Knapp, and today I have with me Siegfried Numberger, the founder and managing director of Preisenergie. Siegfried, thank you very much for joining me today.
Thanks very much, Georgia. I'm very excited to be here.
And today we are going to talk about tariff design, I hope. But before we get into that, could you introduce yourself and tell the audience a little bit more about Preisenergie if they're not familiar with it?
Yeah, thanks very much. Yeah, as you said, I'm the managing director of Preisenergie and the founder. And we at Preisenergie, we are specialized in advanced tariff software and price automation for energy retailers.
Okay.
What that means is we enable retailers to dynamically reflect real-time market conditions, network charges, and also consumer behavior, consumer interests in their pricing strategies, ultimately empowering suppliers and consumers to make smarter and economically beneficial and then environmentally friendly decisions.
And how long has Preisenergie been around?
We started with software development in 2016.
Okay, nice. And you are based here in Munich, correct?
Yes, exactly.
Are you only available in the German market or
We
anywhere else?
we also have a customer in Austria,
Okay,
and we are also looking into other European markets.
okay.
We're looking into.
I guess let's just dive right into tariff design. How would you define tariff design?
Basically, tariff design is how you structure the prices consumers pay for electricity.
Mm-hmm.
Whether through standing charges or fixed unit prices or time of use prices or capacity prices or real-time pricing. It's all about how costs such as energy generation, procurement, grid infrastructure, and flexibility services, and also, of course, marketing and service, how these costs are translated into consumer-facing prices. I'd say there's two answers to that question, because the research response to that question would be, how do you set incentives right? How do you make sure that a tariff is cost-covering and easy to implement and all those things?
Mm-hmm.
That's the public policy point of view, so to say. It's the point of view of how do you do tariff design in order to get consumer nudged basically to behave in a way that is conducive to the grid and to the system, energy system. And the other response is, how do you design a tariff from the point of view of energy retailer that is facing competition? So what you need to do is make an attractive offer and wrap all those incentives into a package that is appealing to a customer and recovering. So you have to have a return. That means you need to calculate the cost, and you have to make it attractive to the consumer. And those two components, basically taking the incentives that come from a public policy perspective and translating that into a consumer-facing package or tariff that is attractive to a consumer and is able to withstand competition.
And in your opinion, what are some of the biggest challenges facing traditional energy tariffs today in such an electrified space where there's a rise of decentralized energy resources?
The greatest challenge for those traditional tariffs is a mismatch.
Mm-hmm.
And this mismatch occurs on various levels. But let's start with the most basic mismatch is a mismatch between marginal cost and the price that is charged to the household.
Okay.
And what you can think of is you have, in a traditional tariff design, you have a standing price that is basically a flat price for the entire year for getting connected to the grid, and a unit charge that is also fixed, a fixed price unit charge where you pay for each kilowatt hour that you consume. And the marginal cost for kilowatt hours change throughout the day. And sometimes even you have negative marginal cost. Basically, you have to not pay for electricity usage, but pay for electricity generation and feeding it into the grid.
Okay.
And those negative prices don't translate to consumer in such a fixed unit price, traditional kind of scheme of a standing charge and a fixed unit price. You don't have negative prices, and so you have a incentive to produce energy, to use energy throughout the day, irrespective of the wholesale prices and the marginal cost.
Okay.
And this is one mismatch. The other mismatch is that the dynamic tariffs that you have now required by law are so complicated that it's not appealing to customers. And so you have this, as I mentioned before, this public policy perspective where you want to incentivize and nudge consumers to behave in a certain way, but that's not appealing to consumers. So you have to also translate this, what is good for the grid and what is good for the system, and package it in a way that a consumer can buy it and still have the public policy goals promoted.
Okay, because you and I know that the dynamic pricing does save people money in the end, but because it's so complex to wrap their mind around, the general public is not a fan?
The general public is not really a fan. I think it's only 1.5% of electricity contracts bought that are dynamic. And it's most of the energy retailers have to offer a dynamic tariff, but most of them offer them just to do what they are required by law. They are not trying to promote them and actively sell them. And energy prices for consumers, second mismatch between public policy goals and attractiveness for consumers.
Okay. And where you said that now the utility companies are required to offer these dynamic tariffs or dynamic pricing by law, is that part of the 14A?
It's part of the 14A thing. That's the dynamic or the time of use grid fees. But also there is this wholesale component. It's a different paragraph in the Energiewirtschaftsgesetz. I think it's paragraph 41, I think. I don't recall exactly. And this paragraph requires energy vendors or energy retailers to offer a tariff that changes prices reflecting the price changes on wholesale markets or spot markets. That means you at a maximum it's allowed 1 hour, and as of I believe September or October, June, and the June deadline is cancelled. September or October there will be a 15 minutes bucket. There is two great pros for dynamic tariffs. You save on generation and you save on grid expansion.
Yeah.
There's a couple of cons also.
Yeah.
The first con is it's complicated.
Dynamic pricing and
dynamic pricing, dynamic tariffs are complicated for the consumer. As we said before, we have 96 prices per day, and nobody wants to check their mobile phones every 15 minutes to see whether they should switch on their washing machine or so.
Yeah.
That's nothing anybody would like to do. That's the first big con. Fortunately, we are here with GridX. There's machines who do this steering and managing energy usage. The other big con is that this tariff is not only complicated, but also passing on average market risk. So you have short price changes per day, but those short price changes per day could also mean that you pay on average a lot more than you would have bought if you would have bought this generation capacity in advance. So with a fixed price tariff, in the past you typically have a price, and this price is guaranteed for a year or 2 years. And so irrespective of what happens at wholesale markets, whether gas prices increase, whether somebody stops delivering gas, as has happened in the past, or whatever happens in the market, there's an electricity retailer who has agreed to provide energy for you at a fixed price. So you can plan as a consumer. You know, my electricity bill will be around, based on my consumption, will be around 50 or 100 euros a month. Now, if this average price increases, and we have seen price increases in the amount of double, triple, quadruple the average amount, that would mean you would have to be prepared to cover this risk and pay a lot more. And this is especially not appealing to consumers who would like to not provide that liquidity to pay for electricity bills, for example, at Christmas. So the example that I like is if you want to buy Christmas gifts for your children, you don't want to face a 5-time increase of your electricity bill.
And so then, in your opinion, how does digitalization enable more opportunities for innovation and responsive tariff structures?
Digitization is the prerequisite. Without smart meters, there wouldn't be real-time pricing or dynamic tariffs or anything like that. And without digitization, there wouldn't be the real-time transmission of cost to an energy management system. And without digitization and some statistics and data analytics and all those things, it wouldn't be possible to calculate the risk and the consumer behavior that is required to hedge the energy retailer against market swings and offer an appealing product to the household consumer. So digitization is the prerequisite for everything in this regard.
From your perspective at Preisenergie, what are some promising innovations in tariff design that you are either seeing or exploring?
The first thing is we are looking and exploring tariffs that are combining stable base prices with flexible components that reward smart consumption.
Okay.
So what I mean with that is if you have a stable base price in a way that secures you against market swings, that is already helping to reduce the one drawback that I mentioned before. At the same time, you can keep the short-time market swings throughout the day. You can keep 96 prices and incentivize load shifting throughout the day without burdening the consumer with market risk. So having those smart tariffs or combined hybrid tariffs that combine hedging against market risks and incentives for load shifting throughout the day. That's something that I believe is going to be interesting. And that goes one step further even. You could also think of tariffs that translate the incentives from the wholesale market or from time of use grid fees into a offering where the consumer is only required to provide certain boundaries to an optimization system, and the energy retailer, together with an optimization system, provides for reduced cost so that the consumer doesn't have to think about 96 prices throughout the day at all anymore, but gets a flat price or a fixed price per month or per unit consumed. And the energy retailer, together with the energy management system, takes the risk of how you can optimize the energy usage for specific assets especially. The second thing that I believe is interesting is now from a public policy perspective is with grid fees. What we have now with the paragraph 14a that you mentioned is time of use grid fees. Now, for the first time in the market as of April, and not offered widely because you need a smart meter for that, and DSOs, the distribution system operators, need to make that happen and make actually charge different amounts of money for the different times. So it's the first step, but what you could increase is you could make those grid fees more dynamic, and that means more dynamic in both a time manner, so not have well in advance communicated time of use prices, but have it more dynamic. And the third thing that I believe will be very exciting is having asset-specific tariffs where you have 1 meter in the household, just 1 meter, because that's costly, but having a tariff that is specific, for example, to a heat pump or a charging station, home charging station for an electric vehicle.
Yeah.
And have the energy management system make sure that this charging station or the heat pump is getting the correct tariff within the entire household. And so the electricity provider can set a tariff structure that is geared towards the specific characteristics of a heat pump or an electric vehicle, as opposed to a washing machine or light and typical electricity usage. Because with a heat pump and an electric vehicle, you can actually manage and shift demand. It's a flexible demand. Washing machines are in theory flexible, but it actually requires behavioral change, whereas charging an electric vehicle during the night, the behavioral change there is very small.
Because your system would be controlling the behavioral change for you. Okay. Yeah.
So the only behavior change that is required by you is then to switch on the electric vehicle at night and putting into the charger and let the system decide. So you have to make a decision to have an energy management system and to switch on, or making it possible to let the energy management system decide when you charge. Yeah. Whereas with a washing machine, you actually have to bear the annoying noise of washing at night and prepare everything, and you have to wait for the washing machine, and the laundry is wet and so on. So that's a lot more intrusive.
Yeah, and be a little funny if your washing machine turned on when prices were low, and then all of a sudden prices go high, your washing machine is like, well, but now I'm going to stop.
Exactly.
I'm going to wait for a little bit.
Yes. That's the stupid part. Yeah. That's what you don't want.
Yeah.
And so I think that makes it very clear what I meant before with how can you make it appealing to a consumer. So having 96 different prices per day and having to and requiring a huge behavior change is not appealing to a consumer.
Yeah.
And what you want is something that is requiring next to no change, only very little changes, and a huge savings potential.
Yeah.
That's the ideal world for a consumer.
And then that is where the tariff design would come in and really help solve all of this for the consumer.
Exactly.
Yeah.
That's where tariff design comes in, where you can then, together with an energy management system, for example, design a tariff where you say you have to have your electric vehicle connected to the grid at night, and if you want to, and the energy management system is taking care that it is fully charged the next morning, and if you override the energy management systems too often, it is disincentivized. And if you let the energy management system taking care of charging your electric vehicle, it's incentivized. And so the energy retailer can save money by buying electricity according to this optimized charging schedule, whereas you as a consumer, you don't have to take care about 96 different prices. And you don't have to bear the market risk. And you don't have to basically do anything, because the energy management system, together with the retailer, is setting the boundaries of the usage and not setting different prices. That's a different way of thinking about tariff design.
Okay. And with these three options you just mentioned, or three innovations that you just mentioned, would there be a risk of added complexities or perhaps inequalities from any of them?
Yes. There is obviously localized and dynamic recharges would increase complexity. That's for sure. The first thing that I mentioned, where you reduce complexity, I don't think that's the central goal of those tariff innovations would be to reduce complexity and reduce the risk for consumers. And the same holds true for the third thing that I mentioned with regard to asset-specific tariffs and prices. So I don't think there is a risk in those two regards. There's a risk of increased complexity. What I do see, though, is, as you mentioned, increased inequalities. We just talked about only homeowners or house owners being able to really profit from those changes in energy system. That's already a risk of an inequality.
Yeah.
And then if you make it very complicated and not plug and play, it's the risk that it's only tech-savvy consumers and house owners that can profit from those innovations, and that's an increased inequality, first of all, which is stupid for the acceptance of the energy transition, but it's also stupid because then the energy transition isn't working, because you actually need the electric vehicles to absorb energy when it's generated, and you need the heat pumps widely adopted and the home batteries in order to keep the grid stable and those things.
Yeah.
So we need to have a huge adoption, and a huge adoption is only possible if it's plug and play.
How do you think regulators and providers can ensure this kind of fairness and transparency?
Well, the regulators can make sure that their requirements aren't overcomplicating things for energy providers, energy retailers. And energy retailers are required to think about consumers and not only transmitting cost, and not only forwarding the incentives that are nudging to consumers. That's then consumers feel nudged. That's not what they like. Consumers don't want to feel nudged. They want to feel empowered. And so what you want is for a regulator to have cost savings possible for system for a behavior that is conducive for the system. And those cost savings should be huge enough that people actually participate. That's the regulator part. And what you also want for an electricity provider is making those tariff innovations that are partly required by regulation, making them as cheap as possible in order to increase participation. So what would not be great is if you could actually save because the regulator is lowering prices or requiring to lower prices for example, demand shifting with grid fees or other discounts that you get for behavior that is good for the system. And then if the energy retailers basically take all that money and increase their margin for such offerings, that wouldn't be positive.
And then this might be shifting gears a little bit. What role do you see local energy communities playing in tariff design?
So you pay a lot. It's very binary. Either you pay nothing if you use it yourself, or you pay a lot if you use it from your neighbor. Even though you use it from your neighbor, even though you don't use the transmission system, and even though it's basically neighboring.
And even though the neighbor, they are not paying, but you are paying by using it from them.
Exactly.
By getting it from them.
Exactly.
Okay.
Yeah. So and changing that and making it more local and making it detached from the wholesale market, because then if you're a neighbor, if you're my neighbor, I can offer you my excess electricity for a given price. I can tell you, you get it for 5 cents. And then it's detached from the wholesale market. So you might pay more or less on the wholesale market, but we can make it an individual agreement about that. And if for local communities you get a reduced grid fee, and if you set local prices that are agreed upon by the two parties, then you still need an energy retailer for the times where there is no locally produced electricity. So there's times when there is no PV generation at night, and your neighbor still wants to use some energy. You can't provide it to them. They will have to buy it from the grid. And for that, you need a retailer. And so together with a retailer and together with local producers at reduced grid fees, you could offer a price that is more local and less costly for the entire grid. From a tariff design perspective, that means that you have a third layer. You have not only wholesale prices and grid fees, but you also localized electricity generation prices that individual neighbors or communities agree upon among themselves. And therefore, if you take everything and make a package around that, it adds some additional complexity and adds some additional locality, which is very interesting, I think.
And then looking ahead 5 to 10 years, what does the ideal tariff design look like to you?
In 10 years, the ideal tariff will be personalized, dynamic, and nearly invisible.
And then before you go, I always have the rapid fire question round at the end. So are you ready? To save on emissions, which do you prefer, biking or public transit?
Myself?
Yeah.
Biking is healthier.
And very easy here in Munich. Which energy asset describes you the most?
Oh, that's a hard one. I'd like to think of myself of an energy management system.
Okay, nice. What has been your favorite piece of energy news from the past year?
The favorite news was that there will be time of use grid fees.
Ah, nice.
That's
Yeah,
really cool.
very, very on brand. What is the most energy efficient thing you've done this year?
I've moved to a house with PV panels on the roof. So
Oh, nice. Yeah. What is one clean energy myth you wish people knew more about?
I don't want to go into this whole nuclear discussion now. I do think there is a couple of myths that keep us from adopting more clean energy in the system. One myth would be that with fluctuating generation, you can't have cheap energy prices, and you can't keep the system stable, and you can't keep industry. There has been a lot of research from conservative parts of the of society that clearly show how you can make prices and system prices low enough for an industrial base.
Okay. And then my last one is, can you name a piece of energy technology that you wish actually existed?
Localized dynamic grid fees, I think that would be terrific. Those don't exist at the moment.
Nice. Well, thank you very much for joining me today with the podcast. It was nice to learn a lot more about tariff design.
Thanks very much. It was a great pleasure, Georgia, and great talking to you.
If you'd like to learn more about the world of renewable energy or energy management systems, be sure to check out our website, gridx.ai, where we produce regular blogs and glossaries about the subject. You can also follow us on LinkedIn or on Twitter and Instagram at GetGridX.